Now consider next coordinate system, which is a cylindrical coordinate system or circular coordinate system. Okay. So already we have studied a Cartesian coordinate system. In Cartesian coordinate system, what are the coordinates? X, Y, Z are the coordinates. Similarly, if you consider cylindrical coordinate system, the coordinates are nothing but rho, phi, z. What is the common coordinate or same coordinate in Cartesian and cylindrical? Z here. Z is the common coordinate or same coordinate. Okay. So already we have studied about Z in Cartesian coordinate system. What is Z? Z indicates a length along Z axis. Okay. That is same in cylindrical coordinate system also. Okay. So now we need to understand what is meant by rho and what is meant by phi. Phi coordinate and rho coordinate we need to understand. Okay. Let me explain each one by one. First I am going to explain about what is meant by rho is equal to constant. Rho is equal to constant. Already we have discussed in Cartesian coordinate system that when one coordinate is constant, it represents a plane or surface. Okay. In any three-dimensional coordinate system, one coordinate constant is a plane or surface, but here rho is equal to constant is a surface. It is a surface. Okay. And the surface is given by, consider coordinate axis. Yeah. So here rho is equal to constant is nothing but surface of a cylinder. Consider this cylinder. This is the cylinder. Okay. For the cylinder, radius of the cylinder is nothing but rho. Rho indicates radius of the cylinder. And Z axis is the axis of the cylinder or center of the cylinder. Axis of the cylinder. Then in this case, the entire surface of the cylinder, total surface of the cylinder is called rho is equal to constant surface. Rho is equal to constant surface. That means simply once again, rho is equal to constant is a surface of a cylinder, entire surface of a cylinder, when radius is rho and Z axis acts as the axis of the cylinder. Okay. Let me explain with examples. Here let us consider examples. What is meant by rho is equal to 5 and rho is equal to 10, and what is meant by rho is equal to 0. Okay. Let us sketch these diagrams. Sketch the diagram for them. So first consider cylindrical, first consider coordinate axis. Yeah. Coordinate axis. So in this coordinate axis, first let me tell you what is rho is equal to 5. So you know that this rho is equal to 5 is a surface. It is a surface of a cylinder when a cylinder radius is equal to 5. Okay. So consider a cylinder. When the radius of the cylinder is nothing but 5 units. Okay. Then entire surface of the cylinder is called, this surface is called rho is equal to 5 surface. Rho is equal to 5 surface. Okay. Similarly, consider what is meant by rho is equal to 10. You know that rho is equal to 10 is a surface of a cylinder when radius of the cylinder is equal to 10 here. Okay. So this is the another cylinder. Yeah. Is the cylinder, and consider its radius is nothing but 10 units. Okay. Then the total surface or entire surface of the cylinder, entire surface is called rho is equal to 10 surface. rho is equal to 10 surface. Okay. So then you need to tell me what is meant by rho is equal to 0. Okay. So actually rho is equal to 0, if you observe this one, it says that it is a surface of a cylinder when radius of the cylinder is nothing but 0. Okay. What happens when cylinder radius becomes 0? Here you observe here, when cylinder radius is 5 and 10, it is shown here. When this radius becomes 0, then cylinder surface will coincide with cylinder axis. Okay. So when radius is 0, cylinder surface will coincide with cylinder axis. Okay. What is the cylinder axis? Cylinder axis is nothing but z axis. Is nothing but z axis. Okay. Simply rho is equal to 0 is nothing but z axis, entire z axis or cylinder axis. Okay. Now consider this one. These are the rho is equal to constant surfaces. All these concentric cylinders are called as rho is equal to constant surfaces. Rho may be 5, 10, 20 like that. Okay. So here, what is the height of the cylinder? Here when you consider rho is equal to constant surface, height is not defined or height is unlimited. Height of the cylinder is unlimited. Okay. So there is minus infinite to plus infinite. Here only radius takes the finite values. There is a 0 to infinite. Okay. Now consider, whenever you consider any cylinder, cylinder looks like this with the cylinder axis and cylinder radius is nothing but rho. Rho is the cylinder radius. Okay. Now can you tell me what is the front view of the cylinder? In front view, how the cylinder looks like. Okay. In the front view, cylinder looks like a rectangle. It looks like a rectangle. So this is the cylinder axis and rho is the cylinder radius. Rho is the cylinder radius here. Okay. Similarly, consider what is the top view. What is the top view of the cylinder? If you observe from the top, the cylinder looks like a circle. Looks like a circle and you can observe the radius. Radius of the cylinder is rho. Okay. Just observe this one. So for convenience in the problems or in the theory, sometimes we take a front view and sometimes we take top view. Okay. So this is the front view rectangle for the cylinder and this is the top view which is circle for the cylinder. Okay. So now what I require here is, I require what is the total top view of these concentric cylinders. I need what is the top view of these concentric cylinders. Okay. Once by observing this top view, we can discuss the different important points about rho coordinate. Okay. So till now we have studied about what is rho is equal to constant. Now I will tell you 3 important points about rho by observing the top view of these concentric cylinders. So to draw this top view of this entire diagram, first let us draw what is the top view of this coordinate axis. Okay. If you see from the top, if you observe from the top, which plane we can see or which plane we can observe here? If you see from the top, we can observe xy plane. Okay. In the top view, we can observe the xy plane and it looks like this. So y axis and this is x axis. If you need, you can sketch negative axis also, which is negative y. And negative x axis. Okay. So in the top view, we can observe this xy plane. And here, this is outwards the board, which is z axis, is the z axis. Okay. So now let us draw what is the top view of these cylinders. Okay. So first one, consider rho is equal to phi surface or rho is equal to phi cylinder. Okay. In the top view, this cylinder looks like a circle. It looks like a circle. This is the top view of the cylinder and the radius of the cylinder is phi. So this is called as rho is equal to phi surface or rho is equal to phi cylinder. Okay. Similarly, consider this outer cylinder. Okay. So rho is equal to 10 cylinder. In the top view, this cylinder also looks like a circle. It looks like a circle here. And here its radius is nothing but 10. So this is called as rho is equal to 10 surface. Rho is equal to 10 surface. Okay. Then finally, what is the rho is equal to 0? Okay. You know that rho is equal to 0 is nothing but z-axis. If you see from the top view, how this z-axis looks like? Z-axis looks like a point. Okay. So when observer see this top view, when observer looks in the top view, so this z-axis is towards the observer. Okay. So this is nothing but rho is equal to 0. Rho is equal to 0 is a z-axis. Okay. So now just observe this one. From these two diagrams, I will tell you three important points about rho here. Okay. So first of all, the first and very important point is, what is rho? Can you explain what is rho here? Okay. Generally you say that rho is a radius of the cylinder. Okay. But what is the reference for measuring the cylinder radius? Or we measure the cylinder radius starting from which place or which location? Okay. So you see here, exactly on the z-axis, rho value is equal to 0. No distance from z-axis. Okay. So when you observe this one, rho is equal to 5. It is 5 units from z-axis. Okay. Or 5 units distance from z-axis. And rho is equal to 10 indicates 10 units away from the z-axis. Okay. So simply we observe here and we say that rho is a distance from z-axis. Okay. Or we can say that rho is a radial or perpendicular distance from the z-axis. Okay. So I say that rho is radial or perpendicular distance from z-axis. So this way how we can explain rho. Rho is definitely it is a radial distance from z-axis. Okay. But you know here z-axis. Z-axis is nothing but a line. Okay. We are measuring this rho value with reference to z-axis, where z-axis is nothing but a reference line. It is a reference line to measure rho value. Okay. So we simply say that rho is a radial distance from a reference line. That reference line is nothing but z-axis. Okay. This is the meaning of rho. Whenever we observe in electromagnetic fields, we say that rho coordinate indicates radial distance from z-axis or radial distance from some reference line. Okay. Similarly, consider second important point. What is the second point about rho? Okay. Here, can you tell me what is the range of rho coordinate? What is rho actually? Rho is nothing but a distance or it is a radius. Okay. Distance and radius both are nothing but positive values. Okay. What is the range of positive values? That is 0 to infinite. Okay. So rho value ranges from 0 to infinite. Our rho value takes all the positive values. Okay. Because rho is a radius or distance. Okay. It is the second important point about rho. Okay. Next, third one. Third very important point. Here, what is meant by aero cap? Actually, by observing this, we can say that aero cap is a unit vector. This unit vector should define some direction. That means it represents some direction. Okay. So to understand aero cap direction, first let me explain what is meant by AX cap. Okay. So you know, by just seeing this AX cap means you can say that positive x-axis direction, or I can say like this. So here consider x-axis. So there is a values on x-axis 0, 1, 2, 3, 4 and so on. Okay. So now observe this one. How do we define these unit vectors, or how do we explain a direction of unit vector means? So AX cap indicates or shows increasing x direction. Okay. in which direction x coordinate increases, that is the direction of Ax cap. Okay. So you tell me in which direction x values are increasing. X value is 0, 1, 2, 3 like this. So I will show you increasing x direction like this. This is increasing x direction. Increasing x direction is nothing but Ax cap. Okay. So that means Ax cap is nothing but x axis direction or increasing x direction. Similarly, if you want to define arrow cap direction, okay. So I define like this. It is a increasing row direction is arrow cap. Okay. Arrow cap shows increasing row direction. Now, we need to observe when row value increases, it shows which direction. That you can observe in any one of these diagrams. Okay. So just observe here. You need to see here. Initially, row value is 0. When row increases to 5, it is moving in this direction. Again, when row increases to 10, it is moving in this direction. Okay. Whenever you observe this direction, you know that this is the direction perpendicularly away from z-axis or radially away from z-axis. Okay. This direction is arrow cap direction. This is the increasing row direction. So increasing row direction is nothing but perpendicularly away from z-axis or radially away from z-axis. Okay. So for example, in this diagram, if you want to represent row direction at any location, just see here. I want what is arrow cap direction at this point. Okay. So arrow cap indicates increasing row direction or radially away from z-axis. Okay. So you draw a line radially away from z-axis. That is the direction of arrow cap. For example, you need arrow cap direction at this point. The draw a line which is radially away from z-axis. This is the z-axis, radially away from z-axis. This is the arrow cap direction at this point. Okay. Like this, wherever you require row direction. For example, you need row direction here. Draw a line radially away from z-axis. This is arrow cap direction. Okay. So arrow cap direction at this point. Draw a line radially away from z-axis. This is the direction of arrow cap or increasing row direction. Okay. Like this, we can represent the arrow cap direction. And how do we define this one? Simply, I say that arrow cap is increasing row direction or the direction radially away from z-axis. Okay. So I am going to write the same thing here. So here I write arrow cap indicates increasing row direction or the direction radially away or perpendicularly away from z-axis. You know that z-axis is nothing but a reference line. So that means in electromagnetic fields, if any physical quantity looks like moving radially away or perpendicularly away from a line, a reference line, okay, then its direction is represented with arrow cap. Okay. So for that, let me tell you an example here. Example is, let us consider light emitted from the tube light. Okay. So what is the direction of light emitted from the tube light? We just consider a tube light. Yeah, consider it's a tube light. So how light will travel from the tube light? The light will move radially away from surface of the tube light. Okay. So light will move in different directions like this. Light moves in all the directions like this. Like this. Okay. So now you tell me this light is moving away from this coinciding point. Yeah. The light is moving away from this point. Okay. If you extend this point along this tube light, it becomes a line. Okay. How this light looks like, light direction looks like? Light is moving perpendicularly away from axis of this bulb, axis of the tube light, okay? Or light is moving perpendicularly or radially away from center of the tube light. Center of the tube light is a line, so reference line, okay? Now here, this light is moving radially away from the reference line. Whenever any quantity is moving radially away from a reference line, then its direction should be arrow cap, okay? So here the direction of this light is nothing but arrow cap. The direction is arrow cap. Yeah. So like this, we are going to use a row coordinate in electromagnetic fields. If any physical quantity is moving radially or perpendicularly away from reference line, then its direction must be denoted with arrow cap. It is nothing but arrow cap. Okay. So these are the important points about row coordinate. I think you better understand this row coordinate from these 3 points. So simply rho is a perpendicular distance from z axis or reference line, and it ranges from 0 to infinite, or it takes all positive values. Okay. And arrow cap is nothing but the direction radially or perpendicularly away from the reference line. That reference line may be z axis. Okay. So this is about row coordinate. Now let us see what is meant by phi coordinate. Okay. Now consider next coordinate, phi coordinate. Okay. To understand phi coordinate, first let me explain what is meant by phi is equal to constant. Okay. So consider phi is equal to constant. So already we know that in any 3-dimensional coordinate system, one coordinate constant represents a plane or surface. Okay. Here phi is equal to constant represents a plane. Represents a plane. Okay. So consider coordinate axis. Consider this coordinate axis. Okay. Here consider a plane. This is the plane. Okay. So this plane makes some angle with x-axis. Okay. I consider this plane makes angle phi with x-axis. Okay. Then this entire plane is called phi is equal to constant plane. Phi is equal to constant plane. That means simply you say that phi is equal to constant is the plane that makes angle phi with x-axis. Okay. Here when I say angle, there are 2 kinds of angles here. One is called as a vertical angle, another one is called as a horizontal angle. Okay. So here you tell me this is a vertical angle or a horizontal angle. Okay. So whenever this angle is parallel to the ground or parallel to the earth, okay, then this angle is called as a horizontal angle. Just like a ceiling fan. Whenever ceiling fan is rotating, the ceiling fan rotates by making an angle. That angle is parallel to the ground or earth, okay, which is called as a horizontal angle. Okay. Now this phi is nothing but a horizontal angle. Okay. So simply once again I will explain. The phi is equal to constant is a plane that makes a horizontal angle phi with x-axis. Horizontal angle phi with x-axis. Okay. This is the plane. So to better understand this phi is equal to constant planes, let us sketch the diagrams here. Sketch what is meant by phi is equal to 0 plane and what is meant by phi is equal to 45 plane and phi is equal to 90 plane and phi is equal to 180 plane and phi is equal to 270 plane and phi is equal to 360 plane. So once if you sketch these diagrams, you better understand what is meant by phi is equal to constant plane. Okay. So for that consider coordinate axis. Yeah. I consider coordinate axis and also I consider negative y-axis and negative x-axis. Okay. This negative y-axis and this is negative x-axis. Yeah. So this is origin. So now just see here, what is the first one? First, I said phi is equal to 0. Phi is equal to 0 is a plane that makes a angle 0 degrees with x-axis. Okay. So consider a plane on x-axis. You tell me this plane makes how much angle with x-axis? This plane makes 0 degrees with x-axis because it is on exactly x-axis. Okay. So this plane is called phi is equal to 0 plane. Phi is equal to 0 plane. The plane which makes 0 degrees with x-axis is phi is equal to 0 plane. Similarly, let us consider another plane. Okay. So this makes 45 degrees with x-axis. Okay. Now what is the name of this plane? Phi is equal to 45 plane. Okay. So this is called phi is equal to 45 plane. The plane which makes 45 degrees with x-axis is called as phi is equal to 45 plane. Okay. Similarly, we consider what is phi is equal to 90. So here it says that the plane which makes 90 degrees with x-axis is called as a phi is equal to 90 plane. Okay. So here which makes 90 degrees with x-axis? The angle between x-axis and y-axis is 90 degrees. Okay. So now you consider the plane on y-axis which makes 90 degrees with x-axis. Okay. So this is called phi is equal to 90 plane. The plane which makes 90 degrees with x-axis. Okay. Similarly, you consider next plane phi is equal to 180 plane. What is the meaning of phi 180? The plane which makes 180 degrees with x-axis is called as a phi is equal to 180 plane. You tell me what is the angle between x-axis and minus x-axis? So this forms a straight line. X-axis and minus x-axis will form a straight line. Okay. What is the angle of straight line? Angle of straight line is 180 degrees. Okay. So if a plane makes 180 degrees from x-axis, that plane should move on to the negative x-axis. Okay. So consider here the plane on x-axis, negative x-axis. Okay. So it makes another 90 degrees here. So total angle with x-axis, this is 90 and another 90, totally 180 degrees. Okay. So plane on negative x-axis makes 180 degrees with x-axis. Okay. So this plane is called phi is equal to 180 plane. Phi is equal to 180 plane. Okay. Next one. What is meant by phi is equal to 270 plane? Okay. Here when plane makes 180 degrees with x, it moves on to minus x. Okay. What is the angle between minus x and minus y? 90 degrees. If it moves further 90 degrees and if plane moves on to minus y. So total angle made with x-axis 270. Okay. So consider another plane here. Yeah. So it makes another 90 degrees with negative x. So totally 90, 90, 90, totally 270 degrees with x-axis. Okay. So this plane is called as phi is equal to 270 plane. Okay. Now finally, what is the phi is equal to 360? Whenever any object makes 360 degrees of angle, this is called as a one complete rotation. If any object makes a one complete rotation or 360 degrees, it comes to the starting point. Okay. What is the starting point? Phi is equal to 0. Okay. So this plane itself is called phi is equal to 360 plane. Okay. Phi 360 and phi 0 plane both are same. Okay. So now you can observe all these planes combinedly can be called as phi is equal to constant planes. Phi is equal to constant planes. Okay. Like this we can form a infinite number of planes. Okay. Now just see here, what is the top view of this diagram? If you observe from the top, how this plane looks like? The plane looks like a line. Okay, it looks like a line making some angle phi with x-axis. Okay, so similarly, so if you observe from the top, if you see the top view of this diagram, okay, all these planes looks like a lines. Okay, this looks like a lines making some angles with x-axis. Okay, so now what I require here is, I require what is the top view of this entire diagram. Okay, so if we sketch the top view from the diagram, we can easily understand what is 3 points about phi coordinate. That are what is meant by phi coordinate, what is the range of phi coordinate, what is the direction of unit vector a phi cap. Okay, so let me sketch this. Consider top view of this diagram. So for that, if you see from the top, which plane we can observe here? If you see from the top, we can observe xy plane. Okay, so first sketch the coordinate axis in the top view. Okay, this is y axis and this is x axis. Okay, so let me sketch negative axis also, negative y axis and negative x axis. Okay, so this is z axis, which is outwards the board or outwards the paper. Okay, so now let me sketch each one by one. So in the top view, the plane looks like a line. Okay, if line is on x axis, angle made with x axis, not line actually, if plane is on x axis. Okay, in the top view, plane looks like a line. Okay, when plane is on x axis, it makes 0 degrees with x axis. Okay, so this is called as phi is equal to 0. Okay, similarly, when plane makes 45 degrees with x axis, then it is called phi is equal to 45 plane. Okay, similarly, if plane moves on to y axis, okay, it makes 90 degrees with x axis, so this is called as phi is equal to 90 plane. Okay, when the same plane moves or rotates further 90 degrees, it makes another 90 degrees, which is called making 180 degrees with x axis. So this plane is called phi is equal to 180 plane. Okay, similarly, if you rotate this plane further 90 degrees, it moves on to negative y. Okay, so total angle made with x axis 90 plus 90 plus 90, totally 270. So which is called phi is equal to 270. Okay, when this plane completes one complete rotation, it comes onto the x axis because it is started on x axis, then it is called as phi is equal to 360 plane. Okay, so now these are the phi is equal to constant planes from the top view. Okay, so now observe here, if you consider when we increase the phi coordinate from 0 to 360 degrees, okay, observe any point on this phi is equal to constant plane. Any point on this plane moves along curved path or along the circular path like this. Okay, so just observe this one. Yeah. So here phi coordinate will increase like this. Phi coordinate is increasing like this. Then plane rotates and any point on the plane moves along the curved path. Fine. So by observing these two diagrams, let us discuss what are the 3 important points about phi coordinate. Okay. So from that we can easily understand what is meant by phi. First point, can you define what is phi here? Okay, actually phi is nothing but angle. Phi is nothing but an angle. Okay, so what kind of angle it is, horizontal or vertical? This is nothing but horizontal angle made with x axis. Okay, so we are going to say that phi is horizontal or azimuthal or turn around angle, turn around angle. made with x-axis. Made with x-axis. Okay. Simply phi is nothing but horizontal. It is also called as azimuthal or turnaround angle made with x-axis. Okay. Second point. Second point, can you tell me what is the range of phi? What is the range of phi? Phi is an angle here as shown in the diagram. So phi ranges from 0 to 360. Okay. So I am going to write here 0 degrees less than or equal to phi less than or equal to 360 degrees. Or we can say in radians 0 less than or equal to phi less than or equal to 2 pi radians is the range of phi coordinate. Okay. Next one. Third one and very important one. A phi cap. Unit vector of phi. What is A phi cap indicates? Okay. Already we know how to analyze this direction. A phi cap indicates increasing phi direction. This is increasing phi direction. That means in which direction phi value increases, that is the direction of A phi cap. Okay. Just observe this one. Whenever we increase a phi coordinate, when we increase phi coordinate from 0 to 45, 45 to 90 and 180 like this. So this point is moving along straight line or curved length. It is moving along a curve. Okay. So when we increase phi value, any point on the plane moves along the curved path. Okay. When any object is moving along curved path, how do we find its direction? We need to draw a tangent. Okay. Tangent for that curve at any point. Okay. For example, if you want to phi direction at this point. Okay. So draw the tangent for this curve, increasing phi curve at this point, which gives us A phi cap direction at this point. Okay. If you want phi direction at this point, okay, draw the tangent for increasing phi curve. Okay. That gives a phi cap direction at this point. Okay. So when you require phi direction at this point, draw a tangent that gives A phi cap direction at this point. Okay. So wherever you require phi direction, draw the tangent at that point for increasing phi curve. That gives us A phi cap direction. Okay. So like this we can sketch the A phi cap direction. Now, can we explain how do we explain here? When we sketch this increasing phi directions, so all these directions looks like a tangent for increasing phi curve. Tangents. Okay. All these tangents are around which axis? All these tangents are around z axis. Here it is a z axis. This is a z axis. Okay. So all these are the A phi cap. All the A phi cap directions are tangents around z axis. Okay. For increasing phi curve. Increasing phi curve. Okay. I am going to write the same thing. Or so here A phi cap is increasing phi curve, increasing phi direction, increasing phi direction as tangents, around z axis, okay. So whenever we study about electromagnetic fields, which direction we need to consider as A phi cap means if any physical quantity that is rotating around a reference line, okay, that is rotating around a reference line, then the direction is represented with A phi cap. Okay. Simple example you may consider Ampere's law. Let us consider any current carrying conductor. When current flows through a conductor, straight conductor, surrounding this current carrying conductor, there should be a magnetic field. A magnetic field is formed in the form of circles or in the form of closed loops. Okay. Like this. Okay. So what is the direction of this magnetic field now? So this is the field or this is the physical quantity which is rotating around a reference line, okay, then its directions must be indicated with EFI cap. Its directions are nothing but EFI cap, like this, okay. Yeah. So if any physical quantity is rotating about any reference line, okay, then its direction is represented with EFI cap, okay. That is the meaning of EFI cap direction. So till now we have studied about two coordinates, what is meant by rho coordinate and what is meant by phi coordinate, and we already know what is meant by z coordinate, okay. That is we have studied in the Cartesian coordinate system, okay. So this is the meaning of rho, phi, z in cylindrical coordinate system. These are the coordinates in cylindrical coordinate system, okay. So we have studied about all the three coordinates in the cylindrical coordinate system. There is what is meant by rho, what is a phi, and what is z, okay. So z we have already studied in Cartesian coordinate system, okay. Now let us represent all the unit vectors at a particular point in the cylindrical coordinate system. That means I consider the top view of coordinate axis. This is y-axis, x, and outwards is z. This is minus x. Minus 1, okay. So in the top view, you know that cylinder looks like a circle, yeah, cylinder looks like circle in the top view. Now let us consider any point. I consider this point. At this point, what is the direction of rho, what is the direction of phi, and what is the direction of z, okay. So if you observe this one, so here what is the direction of rho? I defined arrow cap is nothing but radially away from z axis, arrow cap direction, okay. For that draw a line radially away from z axis, okay. So this direction will be arrow cap. At the same point we need phi direction, okay. The phi direction is nothing but a tangent for increasing phi. I consider angle made with x axis is phi. So phi value will increase if you move away from x axis, okay. So draw the tangent for this increasing phi. We get the EFI cap direction, okay. Then what is the angle between arrow cap and EFI cap? Arrow cap is in the direction of radius for the circle, okay, and EFI cap is tangent for the same circle, okay. So then a tangent and radius of a circle will make 90 degrees, okay. So arrow cap is perpendicular to EFI cap. Now AZ cap, okay. So now AZ cap is in the z axis direction, okay. So this is the z axis. In the same direction, AZ cap direction we have to represent here, okay. So here observe this one, circle with dot. This is the AZ cap direction. Now just observe this one. Here if you observe this, so what is the angle between AZ cap and EFI cap? EFI cap is on the board. AZ cap is perpendicular to the board. So angle between EFI cap and AZ cap is 90. Okay. Similarly, angle between arrow cap excuse me. Angle between arrow cap and AZ cap is also 90. So that means I mean to say that arrow cap, EFI cap, AZ cap, these three are mutually perpendicular, are mutually orthogonal at any point, okay. So I mean to say here arrow cap is perpendicular to EFI cap and is perpendicular to AZ cap. So whenever all the three unit vectors are mutually orthogonal in any coordinate system, then the coordinate system is called as a orthogonal coordinate system, okay. So we say that cylindrical coordinate system is orthogonal coordinate system. Orthogonal coordinate system. What about Cartesian coordinate system? In Cartesian coordinate system, you know that x-axis direction ax cap is perpendicular to y-axis direction, ay cap, and both are again perpendicular to z-axis, az cap. Okay. So Cartesian coordinate system also orthogonal coordinate system. So that means I mean to say that here we are going to study about 3 coordinate systems. One is a Cartesian coordinate system, next is cylindrical coordinate system, next is spherical coordinate system. All these 3 coordinate systems are orthogonal coordinate system. Okay, where unit vectors in that coordinate system are mutually orthogonal or mutually perpendicular. Okay, so similarly, can you try to write the unit vector directions at this point? What are the unit vector directions? Aero cap, Fi cap and Az cap. So if you want aero cap, draw a direction radially away from z-axis. This is aero cap direction. Okay, and draw the tangent for increasing phi. This is Fi cap direction. Okay, then z direction is nothing but Az cap direction. There is circle with dot is Az cap direction. Okay, like this, wherever you require, you are going to you can identify the direction of aero cap, Fi cap, and also Az cap directions. Okay. Now let us consider a question here. The question is, which of the following is true? Which of the following is true at a point 0, 5, 0, at 0, 5, 0. Okay, so I give the options here. Option A, aero cap is equal to Ay cap. Option B, Fi cap is equal to minus Ax cap. And option C, aero cap is equal to 5 Ay cap. Option D, Az cap is equal to minus aero cap. Yeah, so this is given here. Here there are multiple answers are there. So not the one option, here the answer is more than one option. Okay, so let us evaluate this one. So here we need to find which option is correct one at the location called as 0, 5, 0. Okay, so where this point is located? Here only y coordinate is non-zero. When y coordinate is non-zero, so these must be present only on y-axis. Okay, just see this diagram. So this is the point I consider is 0, 5, 0. Only y coordinate is non-zero, x and z are 0, so a point must be on y-axis. Okay, so now at this point I am going to sketch aero cap, Fi cap and Az cap. Then we will compare with all these options. Okay, what is the row direction at this point? Radially away from z-axis is aero cap direction. So this is aero cap direction. Okay, fine. Then what is Fi cap direction? Fi cap direction is tangent for this one. This is the Fi cap direction. Okay, what is the Az cap direction at this point? There is simply the direction of z-axis. Az cap. Okay, so now just observe this one. Observe in the diagram. First option, aero cap is equal to Ay cap. This is correct or not? Okay, so here this aero cap is in this direction. Aero cap is in the direction of y-axis. Okay, so y-axis direction is nothing but Ay cap. So at this point 0, 5, 0, aero cap direction and Ay cap direction both are same. So this is right answer. Aero cap is equal to Ay cap. Next one, a phi cap is equal to minus ax cap. So let us take a phi cap direction. Okay. So a phi cap direction is vertically upwards. This is the a phi cap direction. If you observe this one, this is in the direction of negative x-axis. Okay. So a phi cap direction is nothing but minus ax cap direction. Okay. So this is also correct one. Next, observe the third option. Here it is given that a rho cap is equal to 5 a y cap. So without observing this diagram or without knowing about the cylindrical coordinate system, you can directly say that this is a incorrect answer. The reason is that whenever two vectors are equal, then their magnitudes must be equal and their directions must be equal. What is the magnitude of first vector, a rho cap? Here magnitude is 1. What is the magnitude of second vector? 5. Okay. Simply by observing this magnitude, we can say that magnitudes are not equal. So this should not be equal. Okay. This is the incorrect answer. This is the incorrect answer. Next, last one. So here we know that in cylindrical coordinate system and Cartesian coordinate system, az cap is same. Okay. That means in cylindrical coordinate system, az cap is nothing but again az cap in Cartesian. Okay. So az cap will never be equal to minus a rho cap. Or already we have defined that a rho cap is nothing but ay cap. It should not be az cap. Okay. So here answers are nothing but A and also B are the right answers. Okay. So here I am going to explain the conversion of coordinates from Cartesian coordinates to cylindrical and vice versa. That is cylindrical to Cartesian. Okay. So just consider the top view of the coordinate axis. So x axis, y axis, and this is z axis. Okay. So consider a point here, any point. So here any point in the free space can be represented with a Cartesian coordinate system and also with the cylindrical coordinate system. Okay. So if you are representing this point with a Cartesian coordinate system, so this is a length made on x axis. So this is nothing but x coordinate. Okay. Length along x axis, x coordinate. Similarly, it makes some length along y axis. Length along y axis is nothing but y coordinate. Okay. And z coordinate is same in Cartesian and also in cylindrical. And if we come to the cylindrical coordinate system, in the cylindrical coordinate system, what is rho? If you have any point, random point here, the radial distance from z axis is called as a rho, is the rho coordinate. Okay. And horizontal angle made with x axis is nothing but phi, here. Okay. So now in this one, so if we consider this length shown here, this length is parallel to this y coordinate. So I can say this is y here. Okay. So now observe this triangle. So this is height of the triangle is x and width of the triangle is y, and this diagonal length is nothing but rho. Okay. And there is an angle phi here. So from this triangle, we are going to give the relation between Cartesian and cylindrical. Okay. So first let me tell you what is the relation between x, y and rho from this triangle. You know that rho square is equal to x square plus y square. Okay. So this implies what is rho? Rho is equal to square root of x square plus y square. Yeah. Okay. Similarly, from the same triangle, we have an angle phi here. What is the tan phi here? Tan phi is nothing but y by x. Okay. So tan phi is equal to y by x. This implies what is phi? Phi is equal to tan inverse of y by x. And z coordinate is the same in Cartesian and also in the cylindrical. Okay. So now if you observe this one, this is the what kind of conversion it is? So if you know Cartesian coordinates x, y and z values, okay, substitute x, y, z values in the right side, you are going to obtain rho, phi, z values. Okay. It is a conversion from Cartesian to cylindrical. So this is Cartesian to cylindrical conversion. Cartesian to cylindrical conversion. Fine. Okay. Similarly, we need conversion from cylindrical to Cartesian. Okay. For that, again consider this same triangle. From this triangle, can you tell me what is cos phi here? Cos phi is nothing but x by rho. Okay. I write here cos phi is equal to x divided by rho. This implies what is x? Rho into cos phi. Similarly, from the same triangle, what is sin phi? Sin phi is equal to y by rho. This implies y is equal to rho into sin phi. Okay. So then you know that z coordinate is the same in Cartesian and also in the cylindrical. Okay. Just observe this one. So if you observe this one, here if you know rho phi z values, substitute here, then you are going to obtain x, y, z values. Okay. So we are converting cylindrical to Cartesian. Okay. So this is cylindrical to Cartesian conversion. Cylindrical to Cartesian conversion. Okay. So this just concept explains the conversion of coordinates. Okay. But we have one more very important concept called as a conversion of vectors. Okay. The conversion of coordinates and conversion of vector both are different. Okay. So next concept we will see what is the conversion of vectors. Okay. Now let us see the conversion of vectors. Earlier we have studied conversion of coordinates. Now let us see conversion of vectors. Okay. So suppose a vector a bar is given in a Cartesian ax cap plus ay cap plus az cap. Now a bar is in Cartesian coordinate system. Okay. Similarly, if you write same a bar in cylindrical coordinate system, so rho component into a rho cap plus phi component into a phi cap plus z component into az cap. Okay. So let us consider initially. So initially we need to understand a dot product for this one. For example, if you want to find only, if you want to extract only x component from a bar, vector a bar, so just we need to perform dot product with the x cap. Okay. That means let me tell you. So a bar, consider a bar is given in the Cartesian coordinate system. This is given to us. This is what we need to find. We need to find in cylindrical. Okay. Now, so a bar is given in Cartesian. So it is ax cap plus ay cap plus az cap dot ax cap. A bar dot product with ax cap, and it is equal to, now perform this dot product with each term in the a bar. Okay. You get ax into ax cap dot ax cap plus y component into ay cap dot ay cap plus z component into az cap dot ax cap. This is ax cap. Yeah. Ax cap. Yeah. So how do we evaluate dot product? Dot product is given by magnitude of first vector. So because it is unit vector, magnitude is unity. Okay. Into magnitude of second vector. So this is also unit vector, its magnitude is unity. Okay. Into cos of angle between these two vectors. Okay. What is the angle between ax cap and ax cap? For same vectors, angle between the vectors is 0, cos 0, plus ay into magnitude of first vector 1, magnitude of second vector 1, cos of, what is the angle between ay cap and ax cap? It is 90 degrees. Angle between x and y is 90. okay, plus z component into, so magnitude of az cap is 1, magnitude of ax cap is 1 into cos of angle between az cap and ax cap is 90. Angle between z axis and x axis 90 degrees, okay. And here you know that cos 0 is 1, cos 90 is 0, and again cos 90 is 0, okay. So then this equation will be equal to ax into 1 plus 0 plus 0. So we have obtained x component, okay. That means here what we have understand is, if you want to find or if you want to extract only x component from the complete vector a bar dot ax cap, simply dot product with ax cap will find you x component, okay. Similarly, how do you find the remaining components? Y component is given by complete vector dot product with ay cap, okay. Then z component az is given by complete vector dot product with az cap, okay. And the same fashion, how do you find rho component? Rho component is given by complete vector dot product with arrow cap will find rho component, okay. A bar dot product with a phi cap will give you phi component. A bar dot product with az cap will give us z component, okay. Like this we can find out the component, a particular component from the entire vector equation, okay. This is what we are going to use for the conversion of vectors here, okay. So now here it is given that we need to find out, find out a vector in cylindrical coordinate system, but vector is given in the Cartesian coordinate system. To write the vector in cylindrical, you need rho component a rho, we need phi component a phi, and we need a z component az. So just find a rho, a phi, az and substitute in this equation. So we get the complete vector in cylindrical coordinate system, okay. So for that just we are going to use these three formulas, okay. So we find rho component, phi component, z component. So then we substitute here. So we get the complete vector a bar in cylindrical coordinate system, okay, if not in Cartesian coordinate system, okay. So let us do this one. Now let us find out this rho component first, okay. So for that, rho component is a bar dot product with arrow cap, okay. But we know that a bar for us given in Cartesian coordinate system, I substitute a bar in Cartesian coordinate system. That is ax cap plus ay cap plus az cap dot arrow cap, and this is equal to, let us evaluate this dot product with all the three terms in a bar, okay. So x component ax cap dot arrow cap plus y component ay cap dot arrow cap plus z component az into az cap dot arrow cap. Actually to evaluate these dot products, we need to know angle between ax cap arrow cap and angle between ay cap arrow cap and angle between az cap and a phi cap. Then only we can evaluate the dot product, okay. For that, let us consider coordinate axis. I consider the top view of the coordinate axis here. Yeah. So this is x axis, y axis and z axis. This is the top view of the coordinate axis, okay. Now consider any point here, a random point, okay. At this point, first let us sketch what is the ax cap and ay cap directions. So x axis direction gives us ax cap direction. Y axis direction is nothing but ay cap direction. Then what is arrow cap? Radially away from z axis gives us aero cap direction. And this angle made with x-axis is phi. Okay. So phi value increases if you move away from x-axis and towards the y-axis. Okay. So we need to draw a tangent for increasing phi curve. That should be here cylindrical coordinate system, also orthogonal coordinate system, where aero cap is perpendicular to a phi cap. So here this is a phi cap, where angle between aero cap and a phi cap is 90 degrees. Okay. And this angle between this vertically downward line ax cap and aero cap is nothing but angle phi. Okay. So here we know that what is the angle between x-axis and y-axis? 90 degrees. In that a portion is phi, angle phi. What is the remaining portion? This remaining portion is 90 minus phi. Okay. And if we consider aero cap and a phi cap, angle between these two is 90. In that one portion is 90 minus phi, then what is the remaining portion? Remaining portion is nothing but phi. Like this, we can indicate the angles between different unit vectors. Okay. Now from these angles, we can easily evaluate this dot products. Okay. So come to this equation, Ax. So dot product between Ax cap and aero cap. The magnitude of Ax cap is 1, magnitude of aero cap is 1, and cos of angle between Ax cap and aero cap. Okay. See here, what is the angle between Ax cap and aero cap? This is phi. Okay. I am going to write cos phi plus ay into, so for this dot product, magnitude of ay cap is 1, magnitude of aero cap is 1 into cos of angle between ay cap and aero cap. Okay. What is the angle between ay cap and aero cap? This is 90 minus phi. So I am going to write 90 minus phi plus z component into magnitude of z, az cap is 1, magnitude of aero cap is 1, cos of angle between az cap and aero cap. Okay. So aero cap is exactly on xy plane. Az cap is perpendicular to xy plane. Okay. So aero cap is on xy plane, az cap is perpendicular to xy plane. So the angle between aero cap and az cap is 90. Okay. Or az cap, aero cap both are present in cylindrical. Angle between any two unit vectors in cylindrical is 90. So write cos 90. Okay. So then here it will be Ax into cos phi plus ay into cos 90 minus phi is sin phi. And third term cos 90 is 0. So third term will be 0. Okay. So finally I conclude here, rho component will be x component of a into cos phi plus y component into sin phi. Okay. So this is the rho component we have calculated. So in this similar fashion, we need to find the phi component also. Okay. Let us find what is the phi component, and also let us find what is the z component. Okay. Now let us find out phi component. Phi component is given by a bar dot a phi cap. And a bar known to us is in Cartesian. So Ax into Ax cap plus Ay cap plus Az cap dot product with a phi cap. Then it is equal to Ax cap dot a phi cap plus y component into ay cap dot a phi cap plus z component into az cap dot a phi cap. Okay. So just evaluate this one, evaluate all the dot products. Ax into the magnitude of Ax cap is 1, a phi cap is 1 into cos of angle between Ax cap and a phi cap. Okay, just come to the diagram. What is the angle between AX cap and EFI cap? Okay, this is actually angle 90 plus phi. Okay, so 90 plus phi plus y component AY into, so magnitude of unit vector AY cap is 1, EFI cap is 1 into cos of, what is the angle between AY cap and EFI cap? Angle between AY cap and EFI cap is nothing but phi. Okay, this is cos phi plus z component into the magnitude of AZ cap is 1, EFI cap is 1 into cos of angle between AZ cap and EFI cap. Here AZ cap is always perpendicular to this EFI cap. Okay, EFI cap is on xy plane, AZ cap is perpendicular to xy plane. Okay, or in cylindrical coordinate system, all the coordinates are mutually orthogonal. So EFI cap is perpendicular to AZ cap. So cos 90. Okay, so here cos 90 will become 0. So third term will become 0. So x component AX into cos 90 plus phi will become minus sin phi plus y component into cos phi plus third term is 0. Okay, so finally phi component is AX into minus sin phi plus AY into cos phi. So we obtained phi component now. Yeah. So finally, let us obtain what is mean by what is a z component here. So to obtain z component, we need to perform dot product between A bar and AZ cap. Okay, dot product with AZ cap will give you z component. So A bar is given in Cartesian, AX cap plus AY cap plus AZ cap dot AZ cap. Okay, so it will be x component into AX cap dot AY cap plus y component into, sorry, this is AZ cap. We are performing dot product with AZ cap. Okay, so y component into AY dot AZ cap plus z component into AZ cap dot AZ cap. Now AX, what is the angle between AX cap AZ cap? 90. So cos 90 will become 0. Okay, so 1 into cos of angle between AX AZ cap is 90 plus y component 1 into cos angle between y and z is 90 plus z component into 1 into cos of, what is the angle between same vectors AZ cap? 0. Angle between same vectors is 0. Okay, so here cos 90 is 0, cos 90 is 0, cos 0 is 1. So we get only last term z component. So the meaning of this one is that z components are same in Cartesian and also in the cylindrical coordinate system. Okay, so earlier we have written rho component, we have calculated rho component. What was the rho component? Rho component was x component AX into sin phi plus y component AY into cos phi. Now let us write down all the components we have calculated. First we have calculated rho component, that is AX into cos phi plus AY into sin phi. Then we have calculated phi component, AX into minus sin phi plus AY into cos phi. Then z component is AZ. Okay, so we can write this one in the form of a matrix. So just I will write like this. We have calculated rho component, phi component and z component, which is equal to cos phi sin phi. Here cos phi is multiplied with the x component, sin phi is multiplied with the y component. What is multiplied with the z component? 0. Okay, or z component is absent. Okay, then here minus sin phi cos phi, z component is absent. Okay, in this case x component is absent, y component is absent, z component is multiplied with 1. This is 1. Okay, so ax, ay, az, x, y, z components. Okay, so just this is called as a conversion of vector from Cartesian to cylindrical. Okay, if we substitute components of a Cartesian vector, then we are going to obtain the components of cylindrical vector. Okay, once we obtain these components, then you are going to write vector in cylindrical, like a rho into a rho cap plus a phi into a phi cap plus az into az cap. This gives us vector in cylindrical when you know vector in Cartesian. Okay, so this conversion is just called Cartesian to cylindrical conversion. Cylindrical conversion. Okay, so similarly we can do the vice versa conversion. So if you know vector in cylindrical, we can convert into Cartesian also. For that, the simple thing you have to remember is that, so for example, if you want to find vector in Cartesian, okay, so you need x component, y component and z component, okay, which is equal to, so just take the transpose of this matrix, okay, and substitute here. Okay, so this is cos phi minus sin phi 0, sin phi cos phi 0, then 0 0 1 into rho component, phi component and z component. Okay, so just consider transpose of this matrix here. Okay, so just it is an idea how to remember. So here if you substitute components in cylindrical, we are going to obtain components in Cartesian. Once if you obtain the components in Cartesian, then you can write down complete vector in Cartesian, like ax into ax cap plus ay into ay cap plus az into az cap. Okay, so this is the conversion from cylindrical to Cartesian. Okay, so we write here, this is cylindrical to Cartesian. Cylindrical to Cartesian conversion. Okay, so this is the way how we can perform the conversion of coordinates in Cartesian to cylindrical and it is a conversion of vectors from Cartesian to cylindrical and cylindrical to Cartesian. Okay, so next we will move to how to write differential length element, surface element and volume elements in the cylindrical coordinate system. Okay, now consider differential length element in cylindrical coordinate system. Okay, so here we know that length element is a one-dimensional region. Length element is a one-dimensional region. Okay, so length must be constructed with one coordinate. Okay, so consider here in a cylindrical coordinate system, length is constructed with rho coordinate or with phi coordinate or with z coordinate. Okay, so then dl bar is equal to, here I am going to take plus or minus common, that is forward and backward directions or positive and negative directions. Okay, so what is the differential length due to rho? Differential length is d rho, because rho itself is a length or distance. So differential length is d rho and its direction is plus or minus a rho cap, where this plus or minus taken common. Okay, or what is the length due to phi? You tell me here phi is an angle or length. Phi is an angle. Okay, so we have to convert angle into length, then we have to write the differential length element here. Okay, so for that let us consider this diagram. consider top view of the coordinate axis. So this is y-axis and this is x-axis and this is z-axis. Okay, let us consider any point, a random point, and it is located, it is present at location 1. Okay, so what is the radial distance from z-axis? Radial distance from z-axis is called rho. Okay, and the angle made with x-axis or horizontal angle made with x-axis phi. Okay, now let us increase this angle phi by a small amount or differential amount. Okay, so I increase phi by a small amount or differential amount d phi. Okay, then point moves from location 1 to another location, location 2. Okay, so now when we increase phi value by a differential amount or small amount, the point at location 1 moves along the curved path. Okay, so whenever a point moves along curved path, how do you find the length of this curve or length of this arc? Okay, so you know that length of any arc or arc length is given by, so if side length is L, length of side or length of the arm is L, and the angle made by this arc is theta. Okay, then the arc length or this curved path length is given by L into theta is the length. Okay, so according to this one, can you tell me what is the length of this curved path or arc length? So here the length of the side or arm is rho and angle made by this arc is nothing but d phi. Then this total length of the arc is rho into d phi. Okay, so now if you observe, a differential angle d phi will produce a differential length of rho into d phi. Okay, so here we are converting angle into length, angle into length. Okay, a small change in phi or differential change in phi will produce a differential length. That differential length is rho into d phi. Okay, so I am going to say that the phi will produce a differential length of rho d phi. Okay, and it is moving in which direction? Along incrementing phi, that is a phi cap. Okay, or here what is the differential length due to z? Z itself is a already length. This is a length along z axis. Okay, so its a differential length is directly dz and the direction is plus or minus az cap. Okay, so like this we can write down differential length element in cylindrical coordinate system. Here the most important point we need to understand here is, so in the cylindrical coordinate system, rho is a directly length which will produce a differential length of d rho. Okay, but phi is an angle. We need to convert angle into length. Phi will produce a differential length of rho d phi. Okay, and z is directly length which will produce a differential length of dz. Okay, so this is very important point to understand in cylindrical coordinate system. Okay, so once if you understand this point differential length due to rho, phi and z, then we can easily write down what is the differential surface element. Okay, so let us write down what is the differential surface element in cylindrical coordinate system. Okay, so differential surface elements ds bar. We know that surface elements are two-dimensional regions. That means the surface must have two dimensions or should be constructed with two coordinates. Okay, so surface will be constructed with a combination of rho and phi, or the combination of phi and z, or combination of z and rho. Okay, then what is the surface element for corresponding combination of coordinates? Okay, ds bar is equal to, I'll take plus or minus common. What is the area, differential area due to rho and phi? Rho will produce a differential length d rho, phi will produce a differential length rho d phi. So multiplication of these two dimensions or two sides will give us area. Okay, then what is the direction of this surface? So when a surface is constructed with two coordinates rho and phi, then its direction is in the remaining coordinate direction. What is the remaining coordinate? Az cap. Okay, Az cap. R is represented with plus and is represented with product. Okay. So what is the length due to phi? Differential length due to phi? Rho d phi. Differential length due to z? dz. So this is the differential area or small area. And what is the direction of this surface? Remaining coordinate is rho. Aero cap. R and surface element with z and rho is z will produce differential length dz, rho will produce differential length d rho, and the direction is remaining coordinate direction f a cap. Okay. So finally, I will rewrite this one. This is plus or minus rho d phi az cap plus rho d phi dz aero cap plus dz d rho f a cap is the differential surface element. Okay. Similarly, we need to know what is the differential volume element. Okay. So I write here differential volume element. Differential volume element dV. You know that volume is a three-dimensional region. Okay, it is three-dimensional region. So must be constructed with all the three dimensions or with all the three coordinates. Okay, rho and phi and z. So volume element is given by dV is equal to, what is the length due to rho? D rho. What is the differential length due to phi? Rho d phi. What is the differential length due to z? dz. Okay. Then the differential volume element is given by rho d phi dz. Okay. So this is the way how we can write down a differential length element, surface element and volume element. Okay. So whenever we need to perform this line integral or surface integral or volume integral for a cylindrical vector, okay, then we are going to use dl bar, ds bar, dv like this. Okay. So this is about cylindrical coordinate system, and we have covered all the important points we need to understand in cylindrical coordinate system. Okay. So next we will move to spherical coordinate system. Okay.